Hello, Math 7 students. This is Mr. Kraft coming to you from my house by the wonder of technology. The last time we were together face to face, we were talking about fractions. We had just started to get into rational numbers. And so I'm going to do a quick review here and just remind you of some of the things we've talked about and then get into proportions. I believe we did a little bit of proportions, but if we did, it's been a while, and even if we did not, all the more reason to do it. Now, as you know, a rational number the key word is rational number. So a rational number can be written as a ratio, in other words, a fraction, because a ratio is just another way of writing a fraction. So if you had 3 circles and 4 squares, altogether you have 7 objects. So the circles, you have 3 circles for 7 objects. And the way we read this ratio, you read the colon as 2, 3 to 7, which is exactly the same thing as saying 3 over 7 or 3/7. Same way with the squares, the ratio there is 4 to 7 or 4 over 7. So I'm not going to belabor this a whole lot. Just exactly like with fractions, ratios can be reduced. So if you had 3 to 6, well, 3 goes into itself 1 time, and 3 goes into 6 2 times. And it would be exactly the same if you said 3 over 6 equals 1 over half. Or 1/2, rather. 1 over 2, 1/2. And, you know, the question I've asked you many times in class, when is it appropriate? When do you need to reduce the lowest terms? Answer, always. So a ratio, you always want to reduce it to lowest terms if you can. So 2 goes into 10 5 times, 2 goes into 12 6 times, etc. So ratios, you treat them no differently than you would fractions. And you could also make equivalent ratios. So basically what I did here, I basically said both sides divided by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. I could multiply it if I said 3, 30, as long as you do the same to both sides. So 30 to 36, that's an equivalent ratio to 10 to 12. And 5 to 6 is an equivalent ratio, 10 to 12. But usually you will want to go in the direction of reducing it. Okay, so I believe that we have previously talked about solving fractions that are equivalents when there are unknowns involved. So if I had 3 over 4 equals, say, x over 8. Now, in a case like this, it's not at all difficult to see that the 4 was multiplied by 2, so the 3 has to be multiplied by 2, so x equals 6. So that would be the easy way to do it. And if I recall, one of you mentioned that that's the easy way, the way you prefer to do it. I forget who it was that said that. But the proper way to do it is by cross multiplication. I'll explain to you why that's the proper way. You develop the methods on simple problems that you could just look at and answer so that you'll have the techniques to deal with harder problems later. So you always go bottom to top and down. 4 times x is 4x. Bottom to top and down. 3 times 8 is 24. The equal sign drops down. Now, you're solving a very simple algebraic equation here. You're going to divide both sides by 4 to get the x by itself. Why? Because 4x means 4 times x, or 4 dot x. I can't use that symbol for multiplication because it looks just like an x. So anyway, I want to get the x by itself. I do that by doing the opposite. Opposite of multiplication is division. 24 divided by 4 is 6, which you could have told by looking at it. But suppose you had this. 15 over 19 equals x over 70. Now, I'm not going to give you one actually as difficult as this, but I just use a rather extreme case to show why you need to understand this cross multiplication method, even on simple problems where you don't need to use it. I cannot look at this and say what x is, and if I, the teacher, can't, you probably can't either. Maybe one of you can. If so, hey, good for you, but most of us can't. I do my same process. Cross multiplication, which gives me 19x over here. 70 times 15 is going to be somewhat more fun. 0 times the whole thing is 0. 5 times 7 is 35. Carry the 3. 7 times 1 is 7. 8, 9, 10. 1050. I want to get x by itself, so I divide by 19. And that is just a basically straightforward long division problem, because long division is your friend, just like fractions. 19 will go into 105 about 5 times. 5 times 9 is 45. 5 times 1 is 5, 6, 7, 8, 9. 6 would be too big, I think. Let me check that. 6 times 9 is 54. 6 times 1 is 6, 7, 8, 9, 10. Yeah. That would definitely be out. So 5 minus 5 is 0. 9 from 10 is 1. Drop that. And 5 again. So you're going to get 95 again with 5 left over. So 55 and 5/19. Remember, your remainder becomes the numerator, and the divisor, which was the original denominator, stays where it's at. 5/19 you could change into a decimal. 19 is very close to 20, and 5 over 20 is 1 over 4, which is a fourth. So the wavy equal sign means approximately equal. So 55 and 5/9 is very close to 55.25, not quite. Now, I don't know about you, but I could never have looked at this and said, well, gee whiz, x must be 55.25 or close to it. This is why we develop the methods that we use, for a problem like we did before. It's easy to see what the answer is, but a harder problem like this is not so easy to see. So that's why we develop the methods. Okay, let's go back to a very simple problem. 3 over 4 equals 12 over y, just to make it more interesting. Now, if you were to write this in ratio notation, 2 ratios that are equal to each other are what we call a proportion. And in proportion notation, we would say 3:4 equals 12:y. The numbers on top, the 3 and the 12, are always to the left in your proportion, in your ratios. The numbers on the bottom, the 4 and the y, are always to the right. So these guys are always to the left, and these guys on the bottom are always to the right. The order makes a difference. So sometimes, a lot of older books would show this. Sometimes instead of saying an equal sign, they used a double colon, and the way you read that is as. So you would say 3 is to 4 as 12 is to y. And there you say is to. But we're not going to do that. Most modern books use the equal sign, and that's probably easier to follow. The two numbers, or in this case a number and the variable, on the ends are called extremes when you write it in this notation, because they're on the extreme outermost sides. The ones in the middle are called the means. In this context, the word mean just means middle. Like an average is a mean, because what is an average? It's in the middle of all the scores or heights or numbers or data points that you have. So you say multiply means and set equal. Actually, let me phrase that a little bit differently. That's maybe not the best way to put it. It's not wrong, but let me rephrase that actually. So the product means multiplication. Product of the means has to equal the product of the extremes. So I'm going to show you the two different ways of working these problems, and they both work the same way. You get the same answer. Some of you may find one way of doing it easier, and some of you may find another way. You know what? That's all right. So in blue up here, I'm going to show what I showed you with fractions. Now, probably most of you have figured out by now that y obviously is 16, because 3 times 4 is 12, and 3 times 4 is 12, and 4 times 4 is 16. You're multiplying both sides by 4. But we're going to do it the proper way. We need to learn the proper way to do it so that when we have hard problems, like the one I did a few minutes ago, where you can't just see the answer, you can do it easily. Always cross multiply, top to bottom. Bottom to top and down, bottom to top and down. So you get y times 3 is 3y. 4 times 12 is 48. Divide both sides by 3. And 48 divided by 3 is indeed 16. One there. Now, in green down here, let's look at the other way. So means, those mean the middles. So 4 times 12 is the product of the means. The product of the extremes is 3 times y. So you get 48 equals 3y, and well, duh, when you divide it out, just like we did above, and y is going to equal 16, just like it was up here. So it's very easy. It's not hard at all. So that's all I'm going to have right now. The problems will be posted in Google Classroom. We're going to work on those a bit. Some of the problems you may have done before, but we've been away from each other long enough that your minds may have got rusty. Somehow I suspect that you have not been sitting at home doing math for entertainment this whole time. So I'll give you the problems to work on, and when I see those of you who are able to make it in Google Meet tomorrow, we'll talk about it then. See you as soon as possible, and I hope you have a good rest of the day. Goodbye.